Good afternoon. Just check screen is visible.
Yes,
Yes,
sir.
sir.
Yes, sir.
So yesterday we have started. Let me check. Where it is visible again. So I don't. Let us see. If possible, I will stop. So where we were yesterday? Friction. Just we have started friction. Okay, concepts of friction and few things we have studied related to friction. So it is very simple as far as friction is concerned. If we know resolution of forces very well, this one is also very easy to understand. A little application of mind is required. Concepts are there, few terms are there which may feel confusing, but still it is easy to understand. So very slowly we will discuss. Just we have seen yesterday what is friction, in which we have described this friction as well as reaction. Okay, so what is the difference between reaction and friction? We have discussed yesterday. Anybody? Friction is a type of force we have seen, but what is the difference between reaction and friction? Anybody?
Friction is applied for moving body and reaction is for static body.
Okay, that one is good. Again, as far as direction or nature, we can say perpendicularity, parallelism, something like that. So that in that term, what will be
Friction
the difference?
along the surface and reaction acts perpendicular to surface.
Perpendicular to surface. That we have discussed. Good. So frictional force. Instead of friction, we will say frictional force. It will be along the surface, or we can say opposite to applied force. And on the other hand, reaction. When reaction will come into picture, whenever there is action. So we have seen this. Friction is a force between two surfaces that are sliding or about to slide. Okay. Then examples, when we try to push a book along, many more examples we have seen. Friction always works in the direction opposite. It is something like the reaction. Whenever there is action, there is a reaction, something like that. So it is also in the case of same. अरे एवढी नाही. पारखे सरांकडे बघू एक मिनिट. पारखे सर बाहेर. Friction always works in the direction of opposite. Then we have seen advantages. Whether we have seen this advantages and disadvantages. Just check.
Yes, sir. Yes.
Yes, sir.
So advantages, though friction may be good in some cases it may not be good. Okay, it may have some we can say adverse effect. In some cases it may have good effect as well. So friction is responsible for many types of motion. It helps us walk on the ground, brakes in the car, make use of friction to stop the car. Okay, we have seen this. It helps to generate a heat. So during winter we are rubbing our hands. Advantages. Then disadvantages, friction produces unnecessary heat leading to the wastage of energy. In some cases it may produce unnecessary heat. The force of friction acts in the opposite direction of motion. Okay, so friction slows down in the motion, means it slows down the motion. Okay, so due to friction motion may be slowed down, we know. Forest fires we have seen yesterday, it is a cause of friction. A lot of money goes into preventing friction. So when we were yesterday, I have told one of the term called as tribology. So whenever we want to prevent friction, a lot of money may go in either invest or waste, we can say, to avoid the wear and tear. Just check after that whether we have seen frictional force and its significance.
Yes,
Whether
sir.
we have seen
Yes, sir.
okay.
Yes, sir.
Frictional, very good. Frictional force is a resistive force developed between two surfaces. When motion takes place among them. So there should be a motion. Then we want to have a steady resistive force. Unless and until there is no motion, there is no frictional force. We keep in mind. So factors on which frictional resistance depend. This just we have to see. Nature of surface, magnitude of applied force, normal reaction between contact surfaces. That is also important. Then we have seen classification. So this I have told this one again. So this classification we are not going to see this one. Okay. Right now we are not going to deal with this classification, but whatever classification is there on the left hand side, that we are going to see, which is that classification based on motion, static friction, dynamic friction. Static means body is at the rest or it is about to move, but in dynamic friction it occurs when there is a relative motion between the body. So this word we have discussed a lot. What is meant by relative motion? Let's go to conclusion. Yesterday we have discussed this word when bodies are in motion, or dynamic friction will occur when there is a relative motion between surfaces in contact. What is this? What is relative motion?
Difference between motion of bodies.
What? Please repeat. Who is going to tell?
Difference between motion of two bodies.
Okay. Difference between motion, we can say. It is relative. Relative means difference. Just you can write somewhere this word. Relative means difference. Whenever there is a difference in motion, okay, difference or velocity, we are going to call it as a relative. Okay, so here I may write something like this so that once we will revise it, you will come to know that difference, something like this. Okay. Then sliding friction, rolling friction. So dynamic friction is divided into two parts, sliding and rolling. So that also you can see. Laws of static friction. Static means body is at rest or it is about to move, static. And what is dynamic? Bodies are in motion. Okay. Then the force of friction always acts. So these are the laws. Just you remember. So just for information, or if it is at all asked in the exam, state the laws of static friction. So left hand side you can give the laws. If it is there asked the laws of dynamic friction, these are the laws. So dynamic friction and static and dynamic, these terms are now well familiar to you. Body is in motion, dynamic, body is at rest, static. Or not only body is at rest, suppose it is about to move, then also we are going to call it as a static. That we are going to see. Okay. Further, today we will see these terms: limiting equilibrium and limiting friction. Are you able to see on the screen?
Yes, sir.
Yes,
Yes, sir.
sir.
Yes, sir.
Okay. Limiting equilibrium and limiting friction. Before that, I will ask question. Have you come across the term limit in your mathematics? Hmm? Limit. Have you come across this term limit?
Yes,
Yes,
sir.
sir.
Maybe in,
Yes,
Yes,
sir.
sir.
in what respect you were using this term in mathematics? Limit. Hmm? कशाला म्हणायचं limit in general also. Don't worry. Don't go to mathematics as well. But what is limit? कशाला म्हणता येईल limit? This word is very familiar. Limit. बस झालं म्हणतो आपण. Limit झालं. What is that? कशाला म्हणता येईल limit?
Capacity.
Capacity
Tends to.
tends to. Okay. Again, let's. What is there in your mind related to limit? What do you understand by limit? Hmm? Hmm? What? I'm not getting clear voice. Who is there? Dattatray? I am unable to get your voice. Who is this Kadam SA? Kadam Kadam SA 2020 AG. What you have written? Your name? Kadam SA. Who is this? SA Kadam SA. Am I audible? Just wait. Hello,
Yes, sir.
Kadam. Is there any Kadam in our class? If not, I have to remove from the class. So try
Yes,
to
sir.
take care.
I rename myself.
Kadam is there.
Rename yourself. Okay. Please rename yourself first with your roll number. Those who will not enter with the roll number, I am going to remove from the class. Yep, your roll number and your name. Rename yourself. Who is Kadam? Just check. Okay. What we were discussing this limit. Maybe in your integration. Maybe in your integration. Maybe I don't know. So x is equal to 0 to x is equal to suppose to whatever. What is this? X is equal to 0 to 2 means x is having value 0 to 2 means forget about it. What is limit? Limit means extreme condition. In our subject, it means extreme condition. Limit. So in both the terms, limit word is there. Limiting equilibrium and limiting friction. That's why I have just thought it. So limit means extreme. So whether in your this integration, whether you have in this integration x is equal to suppose to 0.1 अशी व्हॅल्यू घेऊ शकता का तुम्ही x is equal to 2.1 where but limits of integration are x is equal to 0 to 2 त्याच्यामध्ये 2.1 येईल का because it is beyond
No.
limit लिमिटच्या बाहेर झालं automatically so extreme condition here we can say extreme values in mathematics but in our subject we have to say extreme condition limit means extreme condition coming back to limiting equilibrium now few terms are there now hereafter so you should understand very well so try to understand it what does it because at the end you may feel that all terms are same okay that's why I'm telling well in advance you should listen these terms very carefully if it is understood well and good very good so limiting equilibrium so what is equilibrium this term is also known to us now very well what is equilibrium are you aware about this term equilibrium
Yes, sir.
what is that
Body is at rest.
body is at rest is it correct
Irrespective of forces.
Irrespective of the forces acting on that body.
that is important otherwise we can say body is at rest or stationary so we can't understand whether the some forces are applied on the body or not our second chapter name of that chapter itself is equilibrium so once equilibrium word will come into picture immediately you should understand what does it mean by equilibrium irrespective of number of forces acting on a body is at rest why it is happening माहित पाहिजे this is the basic concept of this chapter why it is happening असं काय होतं though the number of forces are acting on a body is at rest why it is happening we have discussed a lot many times this thing कशामुळे होतं
Equal and opposite forces resist करतात.
equal and opposite forces
Resultant of
resist
forces
करतात
is zero.
हा
Resultant of forces is 0.
okay resultant of forces is 0 equal and opposite forces okay again मला exact answer पाहिजे means you are not coming to the point you are just moving around the point okay
Force
exact point.
balance
काय
करतात.
आपण- yes I want that word forces are balancing each other I want that word balance हे सगळे forces काय होतात balance होतात एकमेकांना all the forces are getting balanced to each other. That's why that body remains at rest or at stationary position. Other thing, resultant is becoming zero, etc. Okay, that is good, correct. But balancing is happening. Just check, I'm audible. Balancing is happening. That's why that body is remaining at rest. Now coming back to limiting equilibrium. So why it is called as limiting equilibrium? So it is the condition in which body is just on the point of motion in the direction of applied force is known as limiting equilibrium. So here applied force is equal to friction. Applied force is equal to friction. So we can apply conditions of equilibrium. So what we can say here, limiting equilibrium means what? Limiting equilibrium means what? We have seen equilibrium means what? Body is at rest. Okay, irrespective of applied force, because that forces are getting balanced to each other. But what is limiting equilibrium? Limiting equilibrium means what? Body is still at the rest, irrespective of applied force, but it is just about to move. The body just about to move म्हणजे पुढे चालायला चालू झालेली असते. बॉडी चालू झालं म्हणजे बॉडी इज इन मोशन, असा क्वेश्चन मार्क येईल तुम्हाला. You may be having one question here, whether the body is in motion or is at rest in limiting equilibrium. काय opinion आहे तुमचं? Whether body will be in motion or it will be in at rest only?
At rest.
Yes, sir, at rest.
It will be at rest. It is just about to move. Means whatever force was applied on the body, it is going its extreme limit म्हणतो मी. It is going extreme limit so that body is just about to move. Body is just about to move. It is called as limiting equilibrium. Still, body is at rest. Body is at rest only. इथे का लक्षात बघा, समजलं का कशाला म्हणायचं लिमिटिंग इक्विलिब्रियम? कशाला म्हणणार, कोण सांगू शकते का? Limiting equilibrium means whatever force was applied on the body, it reaches to its maximum condition or maximum value, so that body is just about to move. That force or that condition of the body is called as limiting equilibrium. Can someone explain me this? Let me know. Are you with me or not?
Yes, sir.
Can someone explain this? Just check. Who will explain? What is limiting equilibrium? This is the condition of body. Are you with me? Dipali, roll
Yes.
number 3. Roll number 3. Chaudhary.
Yes, sir.
कळालं काय आहे लिमिटिंग इक्विलिब्रियम? What does it mean by limiting equilibrium? Say yes, no.
Yes, sir.
सांगा मग काय आहे? What does it? What is limiting equilibrium? What is that?
Condition in which the body is just on the point of motion in direction of applied force.
Okay. Means body is in motion or body is at rest in limiting equilibrium? बॉडी मोशन मध्ये असते का मग स्टेशनरी असते लिमिटिंग इक्विलिब्रियम कंडिशनला?
Extreme condition. At rest.
मोशन मध्ये yes, it is at rest. I have written also on the screen. मराठीत सांगतो अजून एकदा. एखादी बॉडी असते, सपोज टेबल वरती एक ब्लॉक ठेवलेला आहे. टेबल वरती एक ब्लॉक ठेवलाय, समथिंग लाईक दिस, सपोज मे बी समथिंग लाईक दिस. वन ब्लॉक इज केप्ट. याला फोर्स लावला इकडून काहीतरी. ठीक आहे. जोपर्यंत फोर्स अशा व्हॅल्यूला पोहोचत नाही की ती बॉडी मूव्ह व्हायला चालू होत नाही, म्हणजे एक्स्ट्रीम फोर्स असं म्हणूया थोडक्यात. एक्स्ट्रीम फोर्स की ज्या फोर्सला बॉडी रेस्टलाच आहे. एक्स्ट्रीम but it is extreme, but it is extreme. That condition of this body is called as limiting equilibrium. म्हणजे इक्विलिब्रियमचं लिमिट संपलं आता इन शॉर्ट. हे एक लक्षात बघा. आता तिथून पुढे बॉडी काय होणार, मोशन मध्ये जाणार. That condition of body is called as limiting equilibrium. That's why word extreme condition I have told here. I have also written extreme condition of equilibrium. Extreme condition झाली equilibrium ची. After that, body is going to move. Okay, after that I am saying, not before that. Just about to move, it is called as limiting equilibrium. Next, limiting friction. Again, word limiting is there. What is that? The maximum friction that can be generated between two static surfaces in contact, which is other, is called as limiting friction. Maximum, I have told already, extreme. So what is friction and what is limiting friction? So maximum friction that can be generated between two static surfaces in contact with each other is called as limiting friction. Friction is a self-adjusting force. It will means we cannot increase or decrease. That's why it is called as self-adjusting force. It will be generated so that limiting equilibrium is achieved. Till it reaches limiting friction. Till this point, no motion will take place. Once force applied is greater than the limiting friction, motion will occur. Just now we have discussed. Up till now, means up to the limiting friction, there will be no motion. But once it will reach its maximum, beyond limiting friction, motion will start. Once force applied is greater than the limiting friction, motion will occur. For two dry surfaces in static, limiting friction is the product of, let it be, that we are going to see. For dry surfaces in statics, limiting friction is product of normal reaction and coefficient of friction. We are going to say that, don't worry about it. Okay, so that is limiting friction. Just you can remember, it is a maximum friction that can be generated between two static surfaces in contact with each other. It is called as limiting friction, and limiting equilibrium is a condition of body. Okay, in which body is about to move due to applied force. It is called as limiting equilibrium. Okay, are you with me? At least we should know these terms. What is limiting equilibrium? Equilibriumचं लिमिट संपलं आता, तिथून पुढे बॉडी मोशनला जाणार. Something like that. And limiting friction is maximum friction between two surfaces, beyond which motion will start. Are you with me?
Yes, sir.
Sir.
Try to understand few terms. It may be simpler. Next, coefficient of friction. Have you come across this term, coefficient of friction?
Yes,
Like
sir.
me? Okay. If you have knowing is good thing. What is this symbol? The symbols now काय हो? What is the symbol of
Mu.
this coefficient?
Mu.
Very good. Mu. So what is that? Just see now. Very simple. This term is going to come again and again. ही टर्म आपल्याला बऱ्याच वेळा पुढे येणार आहे. That's why we should remember it very well. The limiting friction F and the normal reaction are directly proportional to each other. So here you remember, as we seen, limiting friction is a force, and normal reaction we are going to show it is by R. Okay, so these are proportional to each other. Here it is written F proportional R, directly proportional. So here constant of proportionality is known as coefficient of friction. So whatever we get constant of proportionality, that we are going to call it as a, what we are going to call it as a mu. So definition, the constant ratio of frictional force and resultant reaction is known as coefficient of friction. So this one is most important formula. Mu is equal to R divided by F. So maybe in your multiple choice question, it may be asked the constant ratio Okay, the constant ratio of frictional force and resultant reaction is known as coefficient of friction. Mu. What will be the unit of mu? Hmm? It is a ratio of two forces. So what will be its unit?
No unit.
Unitless.
There will be no unit. Unitless, and it is a scalar quantity. So these things are important here as far as multiple choice questions will be there. It has no unit and it is a scalar quantity. Okay, coefficient of friction depends on the objects in contact and their roughness. So this one is also important. Its range is, I will not go in more detail, but its range is 0 to 1. Its range is 0 to 1. So that is called as coefficient of friction. Are you with me?
म्हणजे कोएफिशियंट ऑफ फ्रिक्शन 1 पेक्षा जास्त नाही का येणार सर?
नाही. इट विल नॉट बी. तो नेहमी तुमचा जो कोएफिशियंट फ्रिक्शन येणार तो 0 पॉइंट समथिंग येणार. 0.5, 0.74, 0. whatever, 38, whatever. And it is a ratio of two forces. Which are they? इकडे बघा कुठल्या कुठल्या. आता थोडस डीप मध्ये जातो. एक सरफेस आहे त्याच्यावर एक ब्लॉक ठेवलेला आहे त्याचं काहीतरी वेट आहे. ओके, आता आपलं काय म्हणतो आपण लिमिटिंग फ्रिक्शन और लिमिटिंग इक्विलिब्रियम. म्हणजे याला काहीतरी फोर्स अप्लाय केलाय मी, समथिंग लाईक टी. याला मी फोर्स अप्लाय केलाय. ओके, whether body is in motion in limiting equilibrium,
No.
नो.
body will not be in motion. Still there will be a frictional force. त्याला काहीतरी फ्रिक्शन, कारण फोर्स तरी आपण अप्लाय केलाय. सपोज हा फोर्स 50 न्यूटन ज्यावेळी मी लावेल त्यावेळी ही बॉडी मूव्ह होती. सपोज once that force will reach 50 newton, that time only this block is going to move. Suppose, but instead of 50, suppose I have applied, suppose maybe 49.99, it will not move for that force. Okay, at that time there will be a little friction or body will oppose that force. म्हणजे बॉडीची कॅपॅसिटी आहे 49.99 ला अपोज करण्याची, but it can't oppose. Suppose the example we are taking, it can't oppose this 50 newton force. This at this, असं म्हणणार का आपण इथं, can we say like this here? So when a force of suppose 49.99 were applied, body don't have some oppose. म्हणजे या फोर्सला काय बॉडी अपोजच करत नाही असं मिनिंग होतं का याचं? थोडस विचार करून पाहिलं तर फोर्स किती लावलाय 49.99. वेदर बॉडी विल अपोज टू दिस फोर्स, या फोर्सला अपोज करेल का बॉडी? व्हॉट डू यू फील? करेल का नाही करणार?
यस.
Yes, sir.
Definitely it will occur. Definitely it is going to happen. Why? Because whenever action there is a reaction. हे आपल्याला माहितीच आहे मेकॅनिक्स मध्ये. Because this is also force. So here frictional force will occur, something that we are going to denote by F. Here also it is frictional force. We are going to denote it by force. This. On the other hand, when it is going to reach limiting friction, that body was not in motion, means whatever its weight will be there. म्हणजे याचं काहीतरी वेट असणार आहे इथं. Maybe suppose W, the body's weight. Whenever that weight will be there, this weight is going to apply vertically downward. So here there will be normal reaction. So I will say it as a suppose maybe N, or I will say R. So these two terms, frictional force in opposite direction to applied force, and this normal reaction opposite or perpendicular to, we can say its weight, or along the weight, we can say along the weight in opposite direction. Okay, so this F by R, this F by R is equal to mu. याला mu म्हटलं जातं, coefficient of friction. Okay, coefficient of friction. This term is known as coefficient of friction. Okay, so you remember this. It is the ratio of frictional force or limiting friction and normal reaction. Mu is equal to F upon R, or F is equal to mu R. So R is what? Reaction. In our earlier, what we can say, first chapter, we have taken R as a resultant, but here this R we are going to take it as a reaction. थोडंसं notation, it may be confusing. Sometimes we are taking as a resultant, sometimes we are taking as a reaction. It may confuse. So don't be confused. Be a conceptual. What is coefficient of friction? Ratio of limiting friction and normal reaction. Normal means perpendicular. F upon R equal to mu. Okay. So its value will be 0 to 1. Next. Are you with me? Coefficient of friction.
Yes,
Sir,
sir.
इथं mu is equal to R upon A आपल्याला आहे मग.
Kuda? Sorry. Here. Okay. It should be what? F upon R, no? F upon R. It should be F upon limiting friction divided by normal reaction. Angle of friction. What is this notation? बघा आपण एक वन बाय वन आपल्याकडे नोटेशन यायला लागलेले आहेत. मी विचारणार व्हॉट इज नोटेशन ऑफ लिमिटिंग फ्रिक्शन. नोटेशन पण कुठेतरी थोडीशी लिस्ट करा आहे. आपण लिमिटिंग फ्रिक्शन और फ्रिक्शनल फोर्स बाय व्हाट नोटेशन वी आर गोइंग टू शो एफ. ओके, व्हाट बाय व्हाट नोटेशन वी आर गोइंग टू इंडिकेट आर. आर काय इंडिकेट करणार आहे?
Normal reaction.
Normal reaction.
Normal reaction. And what notation we are going to use for mu?
Coefficient of
friction.
Coefficient of friction. Next. असे बरेचसे symbol येणार आहेत. Next one is angle of friction. What is that symbol?
Phi.
Phi.
Angle of friction is phi. Let us see now what is that. Okay, phi. When this definition, when body is in limiting equilibrium. बघा हा शब्द परत येतो. You can see this word. We are coming across this word again and again. Limiting equilibrium. When a body is in limiting equilibrium, then angle between the resultant reaction. Now here our resultant name is given as S. Yes, and why you may come across a question why it is called as S, because R notation is already given for what? Normal reaction.
Normal reaction.
R notation already we have denoted to normal reaction. That's why here resultant reaction S and normal reaction R is called as angle of friction. बघा काय म्हणता येईल? It is just angle. Angle of friction is nothing but it is a just angle. When body is in limiting equilibrium, then angle between the resultant reaction and normal reaction is called as angle of friction. It is denoted by phi. It is again dimensionless quantity, and resultant reaction S is equal to under root usual R square plus F square. Further, tan phi is equal to, you can say tan phi is equal to front side F divided by R. What is this F divided by R?
Coefficient.
Here,
Coefficient of friction.
coefficient of friction. It will see like this. So here F is there, so it will also become F. So opposite side divided by adjacent side. It may be again, maybe it is something like this. Again it will be mu, but that we are going to see. Not now, but in next slide. So what is angle of friction? It is denoted by phi. When body is in limiting equilibrium, then angle between the resultant reaction S and the normal reaction is called as angle of friction. It is denoted by phi. Again dimensionless quantity. So you can see angle made with, we can say normal reaction. Angle made with normal reaction by whom? By the resultant reaction. Normal reaction ची resultant reaction ने केलेला angle म्हणजे काय झाला? Angle of friction. In other words, otherwise this definition also you can remember for a while. Okay, so it is denoted by phi, and it is the angle between, we can say, normal reaction and resultant reaction, or angle made up with normal reaction by resultant reaction. That one is also okay. Okay, so this is angle of friction. Next, Have you noted down? Are you noting down this?
Yes,
Yes.
sir.
Yes, sir.
Try to note, because many more terms are there further. बऱ्याचशा terms आहेत. That's why you should note it. Okay. Angle of friction we have seen now. Relation between coefficient of friction, which we are doing denoted as mu, and angle of friction phi. Very simple. Just now we have seen what is that. म्हणजे मी इथं पण सांगितलंय बघा की actually what is the, we can say, whatever it is there on the next slide, it is covered here only. Phi means what? Phi, angle of friction. And then what is mu? Mu ला काय म्हटलं जातं?
Coefficient of
Coefficient
friction.
of friction.
Coefficient of friction, and phi is the angle of friction. So what is the relation between these two? Multiple choice question. Always it is asked in multiple choice question. You remember this as well. Only it is shown here. Let us consider the following figure. Okay, there is one block on the surface. Then force P is applied, and as usual, whenever we are going to consider that body, or we can say block, will be in limiting friction. Okay, so its weight is W, which will be acted vertically downward. As it is going to applied vertically downward, there will be normal reaction R. So here from the figure, tan phi is equal to F upon R. What's the way? Just we have seen. So this will be F. So tan phi is equal to F upon R. Also, we know tan phi is equal to F upon R is equal to, here it is already we know, F upon R, definition of coefficient of friction. So this is the reaction. This is the relation between angle. So sometimes coefficient of friction is given in the problem. Sometimes coefficient of friction is given and we are supposed to find phi. What is phi? Phi काय आहे आणि mu काय आहे? These two terms. What is mu?
Coefficient
phi?
of friction.
Coefficient of friction.
Coefficient of friction.
Phi is coefficient of friction. Okay. Coefficient of friction, and what is this?
Angle
of
Angle of friction.
Angle of friction. What is the relation between them?
tan phi is equal to mu.
Tan phi is equal to mu. Tan phi is equal to mu. That also you have to remember. Next. So this relation you should know. Tan phi is equal to mu. Next now. Angle of repose. Have you come across this term? Angle of repose.
No, sir.
Okay, no issue. What is angle of repose? What is this notation?
Alpha.
Alpha.
Okay, you know better. It is alpha. So definition now, just very simple again. Only now, instead of horizontal plane, inclined plane is taken. Nothing else. Only that is the change. See here now. It is the angle made by inclined plane with the horizontal. When the body is placed on the plane, it is just on the point of moving down the plane due to its own weight. काय समजलं सांगा? If not, I will tell. Just try to read it. Just try to read it. If not, I will tell what is there. Let me know your understanding. कोण सांगतंय बघू. Just read it, first 2-3 lines, and let me know. Can someone try to explain what do you understand by angle of repose?
The body is at point to change direction due to the motion.
You can use Marathi. मराठीत सांगा काय अंडरस्टँडिंग, व्हॉट यू अंडरस्टँड. या डेफिनेशन वरून काय कळालं तुम्हाला?
मोशन मुळे बॉडी टर्न व्हायच्या पॉइंटला येते.
कशामुळं?
मोशन
त्याच्या वेट मुळे.
वेटमुळं. ओके, ड्यू टू बॉडी वेट. एनी अदर? ट्राय टू रीड इट. कन्सेप्ट फार सोपा आहे, फक्त समजलं पाहिजे काय आहे. एनी अदर? कदम पाटील साक्षी 11.
Yes, sir.
हम्म. वाचा बरं, तुम्हीच होता का मागाशी? काहीतरी वेगळं नाव होतं. कदम पाटील.
Yes, sir. Yes, sir.
Is it your one surname or two? Kadam and Patil or Kadam Patil?
कदम पाटील आहे.
Okay. Is it possible for you to explain? Just check. बघा बरं काय समजलं. What do you understand from this? Angle of repose लगेच सांगता आलं पाहिजे काय आहे अँगल हा. आर्या 26.
Yes, sir.
If possible, you can. Angle of repose. Definition is in front of you. Rohini 50. Shinde. Just check. Are you in a position to tell? Rohini Shinde.
Yes, sir.
Is it possible for you to tell what is angle of repose by looking to the definition from the slide?
मी सांगू सर?
Okay.
एखादी बॉडी इन्क्लाइन्ड प्लेनवर ठेवली आहे आणि ती लिमिटिंग इक्विलिब्रियम मध्ये असेल तेव्हा त्या इन्क्लाइन्ड प्लेननं हॉरिझॉन्टलशी केलेल्या अँगलला अँगल ऑफ रिपोज म्हणतात.
Very good. Good. Exactly. So, what I want this good understanding, Sakshi. So, what it is there on the slide? Just सांगितलं पहिलं लिहिलंय बघा. It is the angle made by inclined plane. Angle of repose हा काय आहे? इन्क्लाइन्ड प्लेन ने केलेला अँगल आहे. कुणाशी अँगल केलेला आहे हा? With whom? Next it is given with the horizontal. Angle of repose is angle made by inclined plane with horizontal. असे किती अँगल असू शकतात? आर यू विथ मी? असा एक अँगल असेल का हो? इन्क्लाइन्ड प्लेन हॉरिझॉन्टलचे किती अँगल केलेले असू शकतात? फॉर दॅट कंडिशन इज गिवन फर्दर. कुठली कंडिशन आहे? ज्या कंडिशनला when the body placed on the plane, it is just on the point of moving down due to its own weight. अशा वेळचा तो अँगल आहे की ज्या वेळेला किंवा ज्या कंडिशनला जो इन्क्लाइन्ड प्लेनवरची बॉडी आहे ती मूव्ह व्हायला चालू होईल ड्यू टू नॉट फोर्स ड्यू टू इट्स सेल्फ वेट. दॅट अँगल मेड बाय इन्क्लाइन्ड प्लेन with the horizontal is called as angle of repose. For you, again I will explain. This is you can see camera just if possible. Horizontal plane. एक horizontal plane आहे आणि त्याच्यावरती काहीतरी ठेवलेलं आहे. Suppose I will keep pen. If possible, you can see. Now, as the surface is horizontal, there is no question of moving a body. Here you remember we have not applied any kind of force on the body. But once we are going to tilt surface or make inclination of surface, मी आता काय करतो surface असा inclined करायला चालू करतो. Okay, with horizontal, and it is a we can say maximum angle for which body is about to move. आता पेन खाली पडला. Okay, so I have reached beyond alpha, so that's why that pen has dropped from the surface. Yes, it is the inclination. It is the inclination made by it is the angle made by inclined plane with the horizontal when the body placed on the plane is about to move or it is just on the point of moving down due to what? Due to its self weight or its own weight. That angle is known as angle of repose. It is denoted by alpha. And here we should remember we don't apply any force on the body, but the body is going to move due to its own weight, or we can say due to its self weight. Have you understood what is angle of repose? Who will explain now? Marathi. You can take help of Marathi. Marathीत सांगा काय समजलं. Angle of repose means what? कुणी केलेला अँगल आहे हा अँगल ऑफ रिपोज? कुणी केलेला आहे आणि कोणाशी केलेला आहे? फर्स्ट थिंग.
इन्क्लाइंड प्लेन
Inclined plane ने horizontal surface शी केलेला.
Okay. Inclined plane ने horizontal से केलेला आहे. 50% answer is over. It is the angle made by
Inclined plane with horizontal.
with horizontal. असे किती अँगल असू शकतात? Whenever there is inclined plane, there number of angles will come. But condition is what? पुढे condition दिली. काय condition आहे? When body placed on the plane is
Body
about
in
to move.
limiting equilibrium.
Or we can say whenever body placed on the inclined plane is in limiting equilibrium असंही म्हणू शकता तुम्ही. Means limiting equilibrium means what? It is about to move, but it is not moved at all. It is about to move just. That angle is known as angle of repose. It is denoted by alpha. Okay, it is denoted. Are you observing here? No any force is applied here on the body. इथे कुठला force apply केलाय का हो या body वरती? But still body is still about to move due to its self weight. That angle is known as angle of repose. Now alpha. So here inclined surface. Here inclined. Now concept of I have told one of the concept. If angle made by inclined surface is equal to what? आपण सांगितलं होतं बघा. Alpha angle आहे इथं. This angle is alpha. So this angle alpha will be equal to what? Angle made by the reaction. Angle made by inclined surface with horizontal. हे वाक्य आठवतंय का बघा बरं आता. Angle made by inclined surface with horizontal is equal to angle made by reaction with whom? Vertical. With vertical. So same concept is applied here. The same apply केलाय बघा. ही तुमची रिएक्शन असेल. R हे तर लिहिलेलं आहे R. Actually in this problem it is shown here. It is also okay, no issue. So angle made by inclined surface with horizontal is equal to angle made by reaction with vertical on that inclined plane, not on any other. This is called as angle of repose. Correct. Next. Have you noted down this? Just check. Let me check. Have you noted down this angle of
Yes, sir.
repose? Yes. Okay. Next one, relation between angle of friction phi and angle of repose. Relation between angle of friction phi and angle of repose alpha. So for that, whatever you are going to observe this diagram, actually it is how this diagram is actually there is one body. इथं काय आहे, एक body आहे whose weight is W. So consider one body of weight W. Okay. W weight ची बॉडी काय केलेली आहे, एका इन्क्लाइंड सरफेस वरती ठेवलेली आहे. अल्फा इज रिपोज अँगल. Okay. Whatever things we are going to observe, only we have to show. Alpha will be a repose angle, we will see just now. It is placed on inclined surface and that repose angle we will see. Okay. Now आता या बॉडी मध्ये सध्या आता इकडे काय केलेलं आहे की ते तुम्हाला दाखवलेलं आहे. Actually initially it will be something like this, a body of weight W. Okay, its weight will be something like this, suppose in this way W. Okay, here angle is alpha this, then W, and then we know once body is put on the limiting equilibrium, it is about to move. ती काय होणार आहे, about to move. आता बॉडीची मोशन कोणीकडे असणार आहे? Where will be the motion? Now one more thing, normal reaction. Name itself is giving normal reaction. It will be something like this. Normal reaction इकडे असेल perpendicular to surface. This will be R Are you with me?
Yes.
Yes, sir.
This will be R, and here angle here alpha is there. Here it is alpha means this one is also with the vertical alpha. Now where body is going to move? In downward direction. Here body कडे चाललेली आहे. Okay.
Yes, sir.
It is going towards the downward side or it is about to go in downward side. So where will be frictional force? मग इथं frictional force कुणीकडे असेल हो? In upward direction.
Upward side.
Upward direction.
It will be something like upward direction. इकडे असेल F. What is F? What is F?
Frictional force.
Frictional force.
It will be a frictional force. This one is the diagram for this. याच्यामध्ये काय असतील त्या suppose F is frictional force. F is frictional force. Okay. Frictional force. Then R is normal reaction. Okay. R is normal reaction. Okay. So angle of repose, whatever it is there. So we have to just what we have to do. This W force. Now here, though it is a vertical. Now in this problem, whenever a plane is inclined one, whenever we want to resolve the forces, we have to resolve along the plane. Now I am not going to use the term now horizontal and vertical. आता मी असं म्हणणार नाही. Resolve the force horizontally and vertically. I'm not going to use this term horizontally and vertically. But what I am going to use the term along the plane and perpendicular to plane. काय म्हटलं मी? Which terms we are going to use while resolution? Resolve the forces in such a way that along the plane perpendicular to plane. आता vertical horizontal चा काय संबंध घ्यायचा नाही. Once we are going to resolve the force, we should resolve along the plane or parallel to plane. Along the plane or parallel to plane, and another one is perpendicular to plane. At what angle our plane is inclined with horizontal? आपल्या plane ने किती angle केलेला आहे horizontal ची? That is angle of repose.
Alpha.
Alpha.
Now, once we are going to resolve this, only one force is there which is inclined. आहे का असं? आता थोडस इथं इमॅजिन करा की तुम्हाला असं वाटेल की W तर हा vertical force आहे. It is vertical weight. How it is inclined? You may feel like this, because it is, we can see it is a vertical, but this we have to, in our consideration now, it is inclined force, because how we are going to resolve the forces here along the plane and perpendicular to plane. So angle made by W is alpha with the vertical. So what will be its vertical component? What will be its vertical component?
W cos alpha.
W cos alpha. And what will be its y component? Sorry, y component itself is W cos alpha, because angle made with y, vertical, or reaction. And what will be its x component? W sin alpha. W sin alpha. Okay, so this is the resolution for this. Okay, so once you will see this diagram, you may, we can say, confused, or we may get a little confused. Why? Because after resolution this diagram came. Also here it is shown F is equal to mu R. Okay, we know only F. Here I have not shown F, but we know F is equal to mu R. We know that. Okay, now whether body is in equilibrium, आपली body equilibrium मध्ये आहे का? हे R काय आहे तुमच्या लक्षात? R इकडे W हे. Okay, now as body is in limiting equilibrium, apply conditions of equilibrium. Apply conditions of equilibrium. Let us apply them. आता ज्यावेळी मी म्हणेल summation fx is equal to 0, how forces you are going to take? Summation fx is equal to 0, suppose I will say. तर तुम्हाला काय कळणार याच्यावरून? Resolve the forces horizontally म्हणायचं का along the surface म्हणायचं?
Along the
Along the surface.
Along the surface.
Along the surface. Already we know. आता याच्यामध्ये प्लस कुठला आणि मायनस कुठलं घेणार? The forces which we are going downward side. whether we are going to take plus or minus, and the forces which are going in upward, that we are going to take plus or minus.
डाऊनवर्ड
Only two.
निगेटिव्ह अँड अपवर्ड असले पॉझिटिव्ह.
Yes. So which forces are passing in upward direction? After resolution, this one is resolution. This is resolved diagram. Resolution, I will say resolution. Which force is passing in upward direction? Yep. Okay. And which force is passing in a downward direction? W sine alpha. W sine alpha equal to
Yes.
0. What is the value of W? Oh, sorry. Yep. Mu r.
येस सर.
Mu r, yes.
Mu r. So let us say mu r is equal to, we will write meanwhile, W sine alpha. Mu r is equal to W sine alpha, equation number 1. We will see what is happening once we are going to apply second condition now. What is second condition of equilibrium? Summation of Fy is equal to 0. Now we have to consider only forces vertically or perpendicular to surface. Which type of forces we are going to consider?
परपेंडिक्युलर टू सरफेस.
Perpendicular forces.
Surface.
Perpendicular to the surface. Now which forces? How many forces are there perpendicular to surface?
2.
Maybe forces. Which are they?
W cos alpha and R.
Yes. So which we are going to consider positive and which we are going to consider negative?
R is
R
positive
is
and W
positive
cos
and
alpha
W
negative.
cos alpha is negative.
R is positive and W cos alpha, no?
Cos alpha.
Cos alpha equal to 0, which will be negative then. So R is equal to W cos alpha, equation number 2. Okay, so let us see what will happen from equation 1 and 2. Shall we divide 1 by 2?
Yes sir.
Let us see what will happen. Divide 1 by 2. What will happen? Mu r divided by this r equal to, okay, W
Tan alpha.
sine alpha. Or we can write directly also cos alpha, that is, it will become, so r will get cancelled. Mu is equal to W.
W कॅन्सल होते की सर.
W cancel होतं.
Sorry, yes. W will get cancelled. Okay. Then what will remain?
Tan
Tan
alpha.
alpha.
And
Tan alpha. And what we want to find? A relation between angle of friction, okay, phi, and angle of repose alpha. Whether
Mu
we
is equal to tan phi.
Tan inverse phi.
no. Whether these are the two required term. आपल्याला कशामधलं रिलेशन फाइंड आउट करायचं आहे? दोन अँगल मधलं. बट व्हॉट इज म्यू? म्यू काय आहे?
Coefficient of friction.
It is a coefficient of friction. We don't want relation between coefficient of friction and alpha, is angle of repose. We want to find relation between angle of friction and angle of repose. So what we can do next?
Mu च्या ठिकाणी tan
Mu
phi.
च्या ठिकाणी tan phi ठेवायचं.
Very good. So we know what? We know mu is equal
Tan
to
phi is equals to mu.
tan phi. So what will happen? Tan phi equal to tan alpha.
Tan alpha.
What will come finally then? Tan phi equal to tan alpha. याचा अर्थ काय झाला? What is the meaning of this? Phi is equal
Phi
to
is equals to alpha.
Alpha.
phi is equal to alpha finally. So this is the relation. Phi is equal to alpha. What is phi?
Angle of
Angle
friction.
of friction.
And what is alpha?
Angle of
Angle
repose.
of repose.
Angle of repose and angle of friction. So you should remember these two terms as well. Okay, so let's go further. Have you understood? So just you can keep in your notebook this. If not, we don't know what will happen online offline. So that's why I have given a derivation. So finally you can remember angle of repose is equal to angle of friction. Final, that is the conclusion. But how it comes, that also you should know. That's why I have written a little. Okay. Final conclusion is what? Angle of friction is equal to angle of repose. So, but how it comes, you should know. Maybe in your somewhere it may come derive the relation between angle of friction phi and angle of repose alpha. Okay, are you with me? Shall we go next?
Yes, sir.
Yes, sir.
Next. Now let us see few problems. Very simple. These problems are the simplest problems provided that you should understand it. जर हे problems समजले तर फार सोपे आहेत फ्रिक्शनचे. If not, it is very difficult because little terms are confusing. थोड्याशा term it may be. If you have understood well, no issue. So let us solve some problems. Who will read problem statement, or shall I give opportunity to? Okay, Deeparaj 55. Deeparaj Patil, just check.
Yes, sir.
Okay, will you read problem statement loudly for all of us?
Yes, sir.
Huh.
A parcel weighing 200 Newton is just on the point of moving horizontally by a force of 52 Newton. What
What is
is
coefficient?
coefficient of friction?
Okay, very good. Thank you. Okay. What it is there? One parcel whose weight is 200 Newton is just on the point of moving horizontally. Means what it is told? What this just word indicating? What is the condition of this parcel? बघा. All of you can read for a while. 2 मिनिटासाठी सगळेजण प्रॉब्लेम वाचून घ्या थोडा. Whether screen is visible, are you with?
Equilibrium.
Yes, very good. It is indicating limiting equilibrium. Good. Try to understand what it is given. So for parcel, weight is given. How much? How much?
200 Newton.
Okay. It is kept on the horizontal surface and a force of 52 Newton is applied. Means let us say P. I will not say F because F term is used for what?
Friction force.
Frictional force. It is used for frictional force. Okay. And what we are supposed to find? आपल्याला काय काढायचं आहे?
Coefficient of friction.
Coefficient of friction.
What is its notation?
Mu.
Actually, this problem is very simple. It may be asked for multiple choice as well. Because nothing is there in this view. Now you tell me what to do. काय करायचं सांगा? Who will guide me in this? What is the formula for mu?
F
Mu
by R.
equal to F by R.
Mu is equal to F upon R. Okay, whether we are knowing F, whether we are knowing R, whether we are knowing F and R.
F is knowing and
Yes.
What?
F is knowing.
How? Okay, F is knowing. How?
Applied force आणि friction force equal असतात.
mu कुठं माहिती? F चा काय फॉर्म्युला आहे तुमचा? कोण सांगतंय? रोहिणी आहात का? हा, कसा काढायचा F सांगा बरं. or we can say, or we can apply, or we can apply conditions of equilibrium. As body is in limiting equilibrium, we can apply conditions of equilibrium. Let us apply. Let us apply summation apex. Let us see what will happen. Summation apex is equal to 0. Horizontal forces. So P positive minus mu R equal to 0. What we will get from this? Can we get anything? Maybe 52 minus mu. We don't know. We want to calculate. And R is also not known to us right now. Okay. It's equal to 0. Let us say equation number 1. Now apply. Now summation Fy equal to 0. Summation Fy equal to 0. So what will happen? काय is summation Fy या diagram साठी?
R
For this
minus
condition.
R minus 200 equal to 0.
R minus 200 equal to 0, which will imply R is equal to
200.
how much? R equal to 200. Therefore, from equation 1. From equation 1. What will you get? Just check. From equation 1. 52 equal to mu into R. R is knowing 200. Just check. So which implies mu is equal to किती येते बघा? Which implies mu is equal to
0.26.
0.
26.
Okay. Is it our aim to calculate this much only?
Yes, sir.
Only this much. And we have seen coefficient of friction lies between, its range is what?
0 to
काय
1.
म्हटलं? 0 to 1. It should come between 0 and 1. So is it coming between 0 and 1?
Yes,
sir.
Yes, sir. Yes. So here frictional force is not asked. Frictional force is not asked. If at all you want to find, is it possible? विचारला नाही. That is different. It is not asked.
त्या डायरेक्ट फॉर्म्युला माहिती आहे म्यू इज इक्वल्स टू एफ बाय आर मग ती एफ इज इक्वल्स टू ते पी 52 डिवायडेड बाय 200 केल्यावर सेम आन्सर भेटते कंडिशन अप्लाय न करता डायरेक्ट फॉर्म्युलानं पण
F is equal to mu R. Okay. पुढे काय करायचं?
नाही म्यू इज इक्वल्स टू एफ बाय आर ते एफ इज
Okay.
इक्वल्स टू पी असते
Okay. That is also good, but this one is the simplest problem. That's why I have not gone for bypass, something like that. That's why. हा problem एकदम सोपा आहे. In that case, we can solve this very easily. But suppose complexity will increase. You will come to know that how complexity is going to increase step by step. In that case, it may not be applied directly. What we can say, your logic is correct. I am not opposing. It is correct. That way also we can get to find frictional force. To find frictional force. What is that frictional force? F is equal to mu R.
You are.
Just check how much it is. It should come. Is it coming? Whatever Sakshi you are telling, just check how much it is coming.
52.
Yes, it should come 52 again. Correct. Vice versa we can say. Or cross checking we can say. Okay. Likewise we can solve this. Likewise we can solve also. Okay, very simple. Body is in not motion, but body is to be about in motion. Okay. Shall I give one problem for you?
Yes.
Yes, sir.
Many more terms we have seen. What is phi? मला जरा बघा बरं तुम्हाला समजेल. What is phi?
Angle of
Angle of friction.
Angle of friction. What is mu?
Coefficient of friction.
Coefficient of friction. What is alpha?
Angle of repose.
Angle
Angle of repose.
Angle of repose. What is R?
Normal
R
reaction.
कशाचा आहे?
No-
Very good. R
Normal
is
reaction.
normal reaction. Normal reaction. Very good. What is F?
Frictional. Frictional
Yes.
force.
Frictional force. Very good. What is W?
Wait.
Weight of the body. What is S?
Resultant reaction.
Very good. Resultant reaction. So that you should know this terminology. Just you should know for your information. हे काय आहे नक्की? And how we have to calculate? That thing you should know. That's why I have told you. Okay. Let's go forward further. Okay. Who will read this problem? Kisan, roll number 60. Roll number 60.
Yes, sir.
Just check.
A, bo-
Are you-
a body of weight 150 Newton resting on a rough horizontal plane and can be just moved by force of 50 Newton applied horizontally. Find the coefficient of friction. Also find the magnitude and direction of resultant reaction.
Okay. Thank you. Once again, all of you just read it and just check what it is given and what we are supposed to find. सगळ्यांनी read करा problem. Let us see what it is given in the problem and what we are supposed to find. Who will tell what is given?
P is equal to 50.
P. Okay. P equal to 50. Again, what is that 150?
Wait.
W.
W equal to 150. Okay. Again, what we are supposed to find?
Magnitude and direction of resultant reaction.
Coefficient of
Coefficient of friction.
magnitude and direction.
कोणाचे?
Resultant reaction.
Resultant reaction.
By what notation we are showing magnitude or resultant reaction?
Yes.
Yes.
Yes. Okay. Then direction.
Theta.
What notation? Theta. We have not came across some notation. Theta. Theta आपण आलोच नाही. आपण ते अगोदरच्या
Hi.
प्रॉब्लेम मध्ये. Hi. We are showing it as a phi. म्हणजे आपल्याला हे टर्म काढायचे. Till now we have not came across theta. मी मगाशीच दाखवले बघा इथे कुठल्या कुठल्या टर्म आहेत. You can see here on this slide. So here there is no theta. Theta कुठे दिसतोय का तुम्हाला? So now just see what we can do. Will you solve this? Problem is similar to earlier problem. If you are not in a position to go further, simply conditions of equilibrium apply. Conditions of equilibrium. Okay, what is that? Summation fx equal to 0. Directly we should go for conditions of equilibrium. How we will tell this P force. So we are going to see it as a P and this is F. So what will be that? P minus F equal to 0. The is 50 minus mu into R equal to 0. But whether we are knowing something from this R, not knowing. So here equation 1. Now summation of Fy equal to 0. Summation Fy equal to 0. What it will become?
R minus 150. R minus
R
150.
equal to 0. R is equal to 150. Okay. Therefore, from equation 1, what it will become? 50 minus mu into 150 equal to 0. So is it possible to get?
Mu equal to 0.333.
0.33.
Yes, sir.
Okay. Therefore, mu is equal to 0.33. Is it coming between 0 and 1?
Yes, sir.
Yes, sir.
Now next, what we are supposed to find next?
Magnitude.
Magnitude of what?
Resultant reaction.
Okay. Now here I will write. Now S is equal to, what is that formula?
Under root R square plus F square.
Under root R square plus F square. Whether we are knowing R, whether we are knowing F.
Yes, sir.
Okay. Whether we are knowing what is the value of F?
50 Newton.
50 Newton.
50 Newton. Because here in equation 1 we got P minus F is equal to 0, which implies, therefore here I will write P is equal to F. Good. What is that? Yes. Equal to under root, what is that?
150 square plus 50 square.
Under root 150 square plus 50 square, no? What is that?
Yes, sir.
Yes. Just check how much it is coming.
158.11.
58.11.
158.11.
158.11 Newton. Okay. Still, what we are supposed to find still?
Direction.
Direction of resultant.
Okay. How to find that?
Tan pi equal to mu.
Okay. Tan phi equal to mu, or that is equal to F upon R. Just check.
Yes, sir.
Yes, sir.
We want to phi. Okay. What is the value then? Is it becoming tan inverse of? Just check.
Tan inverse of 0.33.
Okay. Therefore, phi equal to tan inverse of 0.33. No. Therefore, here I will write phi equal to how much?
18.77.
18.26.
Exactly. How much?
18.26.
18.
Yes, sir.
sir.
18.
18.26.
Okay, 18.26 degrees. Okay. In this way, we can solve the problem. Very simple. Problems are very simple. There is no worry about this. Have you understood this?
Yes, sir.
Yes, sir.
Next. Shall we go next?
Yes, sir.
Yes, sir.
Okay. Let's read the problem, then we will discuss. Who want to read? Who want to grab the opportunity? Let us know. Urvashi, rule number 52. 52.
Yes, sir.
Will you read the problem statement loudly?
A body of weight 2000 Newton at rest on horizontal plane. If coefficient of friction is 0.4, find the horizontal force required to move the body.
Very good. Thank you. All of you once again read the problem. Then we will see how to solve it. Take 2 minutes. Then we will start. Okay. Read the problem, understand it. Then we will start how to solve. Are you able to solve? Just check. Or is it necessary to solve?
800.
Yes, sir.
800
800 newtons.
800 newton, sir.
Yes, sir.
800.
And
Okay. Good. But me uh, let us write first. What is given? Who will guide me first? काय दिले? W. Is it given?
Yes, sir.
Yes, sir.
New.
Okay. How much it is?
2000. 2000.
Okay. 2000. 2000 newton. Okay. What else is given? Mu.
New.
Mu.
Okay. How much it is? 0.
0.
What we are supposed to find?
P.
Huh?
F.
P.
P. P is equal to how much? No. Correct.
Yes, sir.
Okay. What you have did then? काय केलं? Have you gone for some, we can say, shortcut, or you have did our regular procedure, summation effect summation?
Regular procedure.
Okay. Don't go for a shortcut. Okay. So in some of the cases it may be possible, but not in all the cases. So let us apply conditions of equilibrium. So this sentence you should write, apply conditions of equilibrium. Okay, what is that? Summation fx equal to 0. What is that? P minus f equal to 0, which is nothing but P is equal to mu into F, no, sorry, R. R, no? Summation Fy equal to 0. What is that? R minus W equal to 0. Therefore, R is equal to W. That is nothing but R is equal to W. That is nothing but 2000 Newton. From equation 1. From equation 1. P is equal to mu is given, no, 0.4 into R. How much it is? 2000.
Yes, sir.
That is equal to 800 Newton. Therefore, P is equal to 800 Newton. What we have found this force P? What indicate this? P is equal to 800 Newton. What this indicate? काय दाखवतोय हो?
Equilibrium.
Equilibrium?
Limiting equilibrium.
Yes, limiting equilibrium. Okay, very simple. Things are very simple. Only little understanding is required. Shall I give one more?
Yes, sir.
Okay. Just see what it is given. Anisha read. Mayuri Patil, 31. Just check. Are you in a position to read? Mayuri?
Yes, sir. Find
Read the
horizontal
problem.
force required to drag a body of weight 100 Newton along horizontal plane. If the plane is raised gradually 15 degrees, the body will begin to slide.
Okay. Thank you for reading the problem statement. Others now read it carefully and let us see what it is given. Try to understand first what it is given, then we will solve. Find horizontal force required to drag a body of weight 100 Newton. Read it all of you and just let me know what do you understand from this. What it is given? Who will read? Who will tell me? Have you read all? सगळ्यांनी वाचला प्रॉब्लेम हा?
Yes, sir.
Yes, sir.
Yes, sir.
Now tell me what it is given in the problem statement. काय दिलंय प्रॉब्लेम स्टेटमेंट मध्ये?
Weight of body
Okay, very good. How much it is?
100 newtons.
100 Newton. Very good. Next. Anything else is given?
Mu.
Yes.
Yes, sir.
What is
Angle
that?
of
Alpha.
Actually, this word is
Alpha is given, sir.
alpha is given. What is that alpha?
15 degree.
What is the angle alpha? काय नाव आहे ते अल्फा? काय म्हणतो आपण त्याला? What we are calling to it?
Angle of
Repose.
Very good. Angle of repose. At least some of you got this. It is called, because here conceptually it is given. Conceptually, it is not given in terms of angle of repose is this much. On the other hand, it is given conceptually. How? If the plane is raised gradually, काय म्हटलंय बघा इथं, plane is raised gradually 15 degree, the body will start to begin slide. In terms of this, it is given alpha. It's a good thing you have come to know that. Anything else is given? Hmm?
म्यू
एवढ्या दोनच गोष्टी. मी तो दिला नाही. इट इज नॉट गिवन इन प्रॉब्लेम स्टेटमेंट. ऍक्च्युली हा प्रॉब्लेम सोडवल्यानंतर किती येतोय तो दाखवलेला आहे, बट इट इज नॉट गिवन. लेट अस सी. We have to calculate. That's why I have erased this. So let us see what we are supposed to find. आपल्याला काय फाइंड आउट करायचं आहे? What we are supposed to find?
पी
Horizontal force P. We want to find. Or we can horizontal.
Mu.
Mu or P?
P, sir.
पी सर.
Okay, horizontal force P we are supposed to find. Okay. As usual, without considering anything, let's go for let us see what will happen. According to me, mu is not given. Let us see what will happen if mu is not given. काय होतंय बघूया आपण. Apply.
सर म्यू नंतर लागतंय ना.
We will see. बघूया आपण काय होतंय नक्की. Because in problem statement is not given. Why it is not mentioned somewhere?
सर ते हॉरिझॉन्टल फोर्स रिक्वायर्ड टू ग्रॅब बॉडी नंतर ना 15 डिग्री इन्क्लाइन केल्यावर लागतंय ना सर तरी म्यू.
We will see. Is it possible to calculate from given data? Given वरून काढू शकतो का आपण, बघूया ना. अल्फा इज गिवन नो. We will see. Just wait. Apply conditions. Summation fx equal to 0. We know. So what will happen? P minus f equal to 0. Both are unknown. P is not known. Mu is not known. Whether R is known to us? I will write suppose. R माहित ना आपल्याला?
100.
Yes, sir.
Now summation fy equal to 0. So what will be that? R minus W equal to 0, which implies R is equal to W. And how much W is given?
100.
100.
100 Newton. Okay. So R we got. Okay. Now let us see. R we got this. Now alpha is given. Alpha. Can we make use of alpha? Now we have to revise the thing. Now we have to see. Can we make use of alpha?
Yes, sir.
Yes, sir.
यस सर.
काय करणार सांगा बरं. अल्फा दिलाय आपल्याला.
अल्फा इज इक्वल्स टू 5 and tan phi is equals to mu.
Yes, that I want. Correct. We know. आपण पाहिलंय बघा. Relation between I will write in this way. आपण एक relation पाहिलंय बघा just before some time. What was that? Relation between angle of repose and
Angle of friction.
angle of friction. We know what? Alpha is equal to 5. हे आपल्याला माहिती आहे. Okay, or phi is equal to alpha, whatever. That in this way. We know what I have told. Phi is equal to alpha. Angle of repose is equal to, but alpha is equal to 15 degree. Therefore, phi equal to 15 degree. Also one more relation we are knowing. What is that? Mu is equal to
tan phi.
Tan phi.
mu is equal to tan phi. And then what is value of this phi? 15. So tan 15. Just check how much it is coming.
0.26.
0.26.
0.26. So mu we got. And what we want to find? P is equal to F. Correct. Now we want to find P. So P is equal to F. And what is F is equal to? Mu R.
Mu into R.
Mu into R. So what is that? Mu we got 0.26 into what is R? How much it is? 100.
100.
How much it will be?
16.
26.
26.
26. So here I will write. Therefore, P is equal to 26 Newton. Any problem? So that's why I want to tell. Here I have erased this. That's why. दिलेला नाही. It should not given. Otherwise there will be nothing. जर इथं म्यूज दिला तर काय राहतच नाही प्रॉब्लेम मध्ये. Are you getting? That's why I erased this. After calculation, here it is written. After calculation, not before calculation. That's why I have erased it. Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
So if you are knowing terms very well, it is very simple. As I told earlier, if we know the relations, some terminology, some symbols, whatever we have seen, it is very simple. Okay, shall I give one more problem? Many more problems are there. Don't worry. याच्यामध्ये कोणाला काय शंका? Some such problems will be there for exam. At that time, though it will look very easy, if we know relation, then it is easy. इथं थोडेसे प्रॉब्लेम आहेत. That's why you should have a we can say recap after this lecture. थोडंसं लगेच रिव्हिजन करा या पॉइंटची. थोडंसं कन्फ्युजिंग वाटतंय because number of symbols, number of relation it may come. Still further is going to come. Hardly we will solve one more problem. Hereafter we will see. Anything difficult in this?
No, sir.
No, sir.
Next. Patil Sandeep. Patil Sandeep,
Yes, sir.
57. Will you read problem statement loudly for all of us?
A body weighing 12 kilonewton is laying on horizontal plane for which mu is equal to 0.73. 0.7. Determine normal reaction, limiting force on friction, horizontal force required to move it, and angle of friction.
Very good. Thank you. Others also just read it. First understand what it is given and what we are supposed to find. Very simple. Just check, just read. Shall I give some time, 5-10 minutes? Just read all of you, then we will see what it is given and how we can solve. The diagram is little blur, so have a look on this. Okay, what it is given? Can someone guide me? What it is given in the problem statement?
Weight
There is
and
one body on horizontal. Okay, what it is given? Weight? How much it is?
12 kilonewton.
Very good. What is other is given? Coefficient of friction. Okay. What we are supposed to find? Huh?
R, S, and P.
Okay. R. Yes. Somebody told yes.
P.
Limiting force. Yep. Horizontal force P. Is it the case? Or any more we want to find?
Angle of friction phi.
Yes, that also we need to find. So these four things we are supposed to find. Shall I expect answer from you?
Yes, sir.
Okay, take your time. So let us see what will happen. I'm going to ask randomly. So don't tell your answer. I will ask one by one. So just I will say apply conditions of equilibrium. Okay. And here I want answers. So what is your R? I will ask one by one. Don't worry. What is your F? What is your P? And what is your I? Once it will be over, you just keep quiet. I will ask one by one, maybe randomly, not possible. Meanwhile, I will take attendance. Roll number 12 is absent. Roll number 14 is absent. 19 absent. 22. 25. 37. 45. 53. A lot of options in this one. 56. Siddhaling, what is your roll number? Siddhaling Bukka.
14.
You give roll number, no? F14. Absent roll number 19, 22, 25, 37, 45, 53, 56. These are the absent numbers. Roll number 8. 8 roll number.
Yes, sir.
Is it over?
No, sir. Solving.
Okay. Roll number 18. Samarth Chavan. 18.
Solving, sir.
Okay. 27, 27, मदने पाटील, मदने पाटील, प्रणाली, महेश,
Yes, sir.
are you solving?
Solving, sir.
Okay, take your time. Once it will be over, just say yes, it is over. I will check the answers.
Yes, sir. Over.
Yes, sir. Over.
Okay. Others also, quick. Is it difficult or is it easy? Sakshi?
Easy, sir.
Okay.
Or sir.
Who is that? Priyanka, roll number 8.
Yes, sir.
Is it over?
No, sir.
Okay. Continue. So I am taking random name. So don't be feel bad. Those whose names still I have not taken. I think everybody's name I have taken till today. But still it is remained. Don't be feel bad. Just I am scrolling down the your roll call list. Whatever name will come, I am taking. For example, Siddhartha Nare, roll number 54. Is it over? Siddharth? Siddharth? Siddharth means only logged in. Engineering mechanics will be studying by mobile. I feel so. The mobile's काम आहे engineering mechanics लेक्चर ऐकणं. That is not our task. बरेच जण असे रिस्पॉन्स देत नाहीत ते. It may be something like that. Ashwini Madne Patil. Is the case? Ashwini Madne Patil same. Only logged in. Shiv Kumar Bhosle 13. Bhosle Shiv Kumar.
Yes, sir.
बोला सोडवला प्रॉब्लेम
सोडवालो, sir.
सोडवायला लागलाय व्हेरी गुड मानसी 30
Yes, sir. Solve केले.
केलाय सांगू शकता आन्सर सगळे
Yes, sir.
ओके सांगा रिएक्शन किती आली मी सोडवत नाही प्रॉब्लेम आता तुमचे आन्सर
12
लिहितो सांगा
Newton.
किती आलं रिएक्शन हा
12.
ओके 12 किलो न्यूटन असेल हो बघा जरा
हा, yes, sir.
ओके यप
8.4 kilonewton.
8.4 किलो न्यूटन ओके नेक्स्ट टी
8.4 kilonewton.
सेम यस हा नेक्स्ट हाय
34.99 degree.
34.99 means almost 50 35 we can say okay is it correct Sakshi
Yes, sir. Same to same.
सगळ्या व्हॅल्यू बरोबर आहेत सेम आहेत sir.
काय झालं कोण काय म्हणते मध्ये ऋतुजा
नाही सर मी बोलले तिच्या सगळ्या व्हॅल्यू बरोबर आहेत
ओके ओके नो इश्यू एनी अदर कोणाचं वेगळं आन्सर आलंय का प्रियंका रोल नंबर 8 यू आर नॉट टोल्ड आय थिंक स्टिल आन्सर
येस सर ऑल व्हॅल्यूज सेम आहेत फक्त 5 ची व्हॅल्यू चुकली होती
किती किती आली तुमची हा कुणाची चुकली यांची चुकली का तुमची चुकली प्रियंका
सर माझी चुकली होती
ओके व्हेरी ऑफ कमिटेड मिस्टेक
सर 5 कॅल्क्युलेट करताना कॅल्क्युलेशन चुकलं
Okay, very good. Take care. With this, we will stop here. Almost 2 hours we are together. So thank you very much. I have taken attendance. Means few students already left the class. Shall I take attendance once again? म्हणजे काही लोक म्हणजे out of 57 minimum 4 to 5 students are coming only for attendance. That is the meaning of this. It's a good thing. I will identify as such student. Let me check once again. I will check 13, 14. Any problem? Anyone want to tell something, some related to syllabus? If not, we will stop. I can understand it is last 2 lectures we are together. Shall we stop then? Thank you very much for joining. Shall I give one problem while going?
Yes, sir.
Yes, sir.
Just check, is it possible to solve? If not, we will solve. Just note down this. You just try it. Problem is similar to earlier problem. Only change is what? Instead of horizontal force, inclined force is applied. Means there is a body on the surface or horizontal surface. So till now we have seen body will be, we can say, drag or pulled by horizontal force. Instead of that, in this problem, it is pulled by inclined force. That is the only change. Other things are very simple. You try it. Otherwise, we will solve in next lecture. Take the screenshot. We will close. Shall I close?
Yes, sir.
Okay. Thank you very much for joining. Have you taken screenshot?
Yes, sir.
Try to solve. If not, we will solve definitely in next lecture. Don't worry.